Dr. Professor Bong Wie, I would like to ask you, why is a deflection or defense program so necessary for our planet?
Unlike many other natural disasters, such as earthquake, tornadoes, tsunami, volcano eruptions, which cannot be prevented, but asteroid impact threat can be detected in advance, and also it can be prevented. And let's look at recently so-called Chelyabinsk event. It happened about 2 years ago, and it happened without any warning. And it happened early in the morning. And the size of that asteroid was about 20 meters, but it couldn't penetrate the Earth's atmosphere. So the citizens of Russia, they were very lucky not to have major disaster because asteroid was exploded at about 20-kilometer altitude.
Yeah.
So if that happened on the ground, and then can you imagine the effect of that small asteroid? At the same time, actually, everyone in our planet defense community was expecting to see much larger asteroid, which was detected about 1 year ago, but it was sort of planned or scheduled to fly by the Earth with very close distance. But the Chelyabinsk event just happened on the same day without any warning. So those two are clear example of asteroid impact. So can you imagine what if that 20-meter asteroid was 100 meter or 300 meter?
Yeah, well, it would definitely be devastating.
Yes.
Would have had a very big impact.
And we must be ready for developing a plan to avoid such unexpected natural disaster before it can happen again.
Okay. Do space agencies like NASA or ESA possess or are working on such a deflection program?
Yes, there are very small groups within NASA, ESA, or International Planetary Defense Research Community have been studying asteroid deflection disruption problem for many years. However, they have been focusing on early detection and tracking and characterization of asteroids. And our community is not quite ready to deal with the problem of mitigating the impact threat against such asteroid due to many reasons. I think we will be talking about those reasons for not developing real asteroid defense project or program. And your question is why we don't have such existing system.
Yeah.
In other words, we don't have such existing asteroid defense program or project to be ready to be used in the real situations. But the community have been studying a plan to develop such a program.
Okay. So basically, if a big rock would be heading towards a city like New York or London, or what would we be able to do if we would know about it, maybe let's say a year or half a year in advance?
Yes. If we have mission lead time or mission warning time less than 1 year or 6 months, and then our current technology will not be able to design, test, implement system or integrate the system to be ready to be used against asteroid with only about 6 months warning time. So my answer is we cannot do anything about that situation as of now.
Okay. Yeah, that doesn't sound very positive, does it? Okay, but what can we do now with the 10 years warning time? Is there something we can do about them that we know about?
Yes. When we have sufficient warning time, even though we don't have a clear definition of what we mean by warning time. So let's take 10 years.
Yeah.
So if we have 10-year mission lead time, our current technology will be able to develop whole system within about 2-3 years, and we will be able to launch a missions, probably using impactor, and that mission will be able to gently deflect asteroid, something like this. So that mission will start from the liftoff, a launch vehicle, and then this launch vehicle will place a kinetic impactor at the right time, at the right locations. So this kinetic impactor is basically conventional satellite. It doesn't require any new technology.
Okay.
So this conventional spacecraft called kinetic impactor will collide with target asteroid, and it will provide enough or sufficient initial velocity change, and this target asteroid will deviate from its original trajectory.
Okay.
And if you have a 10-year mission lead time, and this trajectory will be sufficient enough to be deflected away from the Earth.
Okay, but still, I can't shake this thought off. With if we know that something's gonna come in a year or half a year, we need to do something. I know you've been working on a specific research. What do you think would be the best method? Obviously not now, but in the future, that we need to concentrate ourselves on. What would be a system that would help us in this short time span?
Yes, so we should understand that if we have sufficient warning time, gentle deflection is the best option. It's the best solutions. We don't have to disrupt, fragment, pulverize, or vaporize target asteroid when we have sufficient mission lead time. So now you are concerned with situation with less than 1 year.
Yes.
If we have only 1 year mission lead time, we cannot assemble launch vehicle with satellite and then launching the mission to have a gentle deflection.
No.
In that situation, disruption is only solutions. Disruption means we launch a mission which carry either kinetic energy impactor or a satellite carrying nuclear explosive device. Those two options will be able to fragment or pulverize or vaporize the target asteroid depending on the size of the target asteroid. So for such short warning scenario, we have to accept that disruptions, fragmentations, or even vaporization is the only options.
All right. Can you explain a bit about this device? I know you've been working a bit on sorry, not device but system. You've developed a concept, and would you be able to explain it a bit? The HIVI concept.
The HIVI stands for Hypervelocity Asteroid Intercept Vehicle, which is just a conventional satellite bus. So the spacecraft is more like a payload of conventional launch vehicle. So for that situations, our HIVI, Hypervelocity Intercept Vehicle, will be placed in the payload section of the conventional launch vehicle, and the whole system, after liftoff, it will fly toward incoming target. And this vehicle will place our HIVI at right locations at right time, but there will be misplacing the payload. So this vehicle, HIVI, will target and acquire this asteroid, incoming asteroid, and will collide with this asteroid. However, it is not just kinetic impactor. This kinetic impactor concept doesn't provide enough energy
Okay.
to disrupt or fragment the target. So our system called HIVE consists of two bodies, conventional kinetic impactor and another section carrying a nuclear explosive device. So the kinetic impactor will collide with the Earth under the asteroid. It will create small crater, probably 20-meter width and 5-meter depth. And then the second section of the HIVE, we call follower or trailing sections, will enter the bottom of the crater and will detonate a nuclear explosive device. That concept has been known to be about 20 times more effective than so-called contact burst. When we have a nuclear explosive device detonation at just above the surface, most of the energy from this device will go other directions.
Okay.
The energy contained in nuclear explosive device. But HIVE concept will be trying to have more energy spread it to the target body. So that will help pulverizing this target asteroid.
Yep.
So we are going after 20-time efficiency factor using HIVE concept.
Okay. How much would it cost to build such a system?
As was mentioned, the HIVE is just conventional satellite. It's just like a maybe 500 kilogram satellite or 1,000 kilogram satellite, which may be carrying 300 kilogram nuclear payload or 1,000 kilogram nuclear payload. So I may say that the overall cost of set a HIVE vehicle should be around between $100 million or $200 million.
Okay. How long will it take to build such a system?
Most scientific satellite will require at least 2-3 years develop and then testing and then retesting the components and then final integration. So it will take at least 1 year to build a real satellite.
Okay. At the end of this discussion, I would like you to ask a bit about what do you think about Emergency Asteroid Defense Project and their initiative?
Yeah, I was quite pleased to hear about your movement and trying to have public to get involved with this very complex engineering, also very complex political problem. The main reason for not having existing asteroid defense program or mission was mainly due to the lack of public support. We cannot blame decision maker or NASA is not having existing mission concept or existing asteroid defense system.
Okay.
Because without public support, it is very difficult to initiate any hardware program to mitigate the impact threat of hazardous asteroid. It is truly complex problem from political perspective.
Yeah. Well, I guess it's good that we get the public involved, and maybe this will show that the public does think that this is a problem and wants to act on it.
Yes. So now is the time
I agree.
to educate the public. You are going to initiate this program called Emergency Asteroid Defense Project to make public understand the impact threat from asteroid.
Yes, that is correct.
This problem has the highest giggle factor. Everybody is just laughing once we talk about the extinction class event happened 65 million years ago. Nowadays, everybody knows about that. But it happens. But most people believe that it will never happen again. But the probability of such extinction class event is extremely small. However, It is not exactly zero. It can happen anytime, sooner or later. But nowadays, our researcher in this field have found out that we don't have to really worry about such extinction class asteroids. So they found out that there are not many 10-kilometer size asteroids which are going to hit the Earth again, as was happened 65 million years ago. So nowadays, we are more concerned about impact threat from smaller size asteroids, the size from 50 meter to 300 meter. They found out that there are at least 1 million small asteroids they couldn't identify, they couldn't track, so they don't know where they are now. But they are trying to find those million asteroids within the next 10 years with sufficient funding from NASA, ESA. So our community has been doing their job in finding those target asteroids with 10 or more than 10-year warning time. Our responsibility through emergency asteroid defense project is to be ready for the situation when we have only less than 1 year.
So basically, we're gonna use the hive system when no other method is viable. When everything else fails, it's not a solution. So the hive basically is gonna be used only as an emergency solution when we have asteroids coming towards Earth with a very short time span.
So in this situation, the public must understand that we, aerospace engineer, cannot build such a system within 1 year. That's too much expectation. Such a system should have been studied, designed, built, tested again, many times, and then should have been pre-deployed to be used in the real situation with such short warning time. That is very complicated political problem to be resolved.
Okay, yeah, I have no further questions, and I would like to thank you for this wonderful discussion. And yeah, it was very nice discussing with you.
Thank you for your interest and your creative initiative for trying to solve this complex problem no one tried to solve.
Thank you.
Congratulations.
Thank you, and thank you for being a part of it.
Thank you again.
Thank you.